Okay, in my last video I promised that I would tell you some uses of completing the square, so that's what I want to do in this video right now. But first let me tell you that what I am about to show you is not the only use of completing the square. It's useful in all areas of math. In fact, I recently found myself staring at a Calculus 2 problem that I stared at it for at least an hour and a half, maybe more, before I realized that I can solve this as long as I complete the square to rewrite it. But one of the most important ones that I'm about to show you is this. Let's take the equation 3x squared minus 5x plus 1 equals 0. Alright, and let's solve this equation. Okay, well the first step is to factor. So we've got, let's see, two terms. The first one's going to be 3x plus or minus something. The second one's going to be x plus or minus something. And let's see what values work. Well, they're going to have to multiply to 1, so, well, maybe 1 and 1, or maybe 1/2 and 2. Let's see. Of all those, which ones will give us -5? Gee, that's tough. I don't know. In fact, we can't factor this. I could sit here all day if I wanted to. But is there a way to solve this still? Is it just no solution, or is there actually something we could do to solve it? That's where completing the square comes in. Alright, in order to complete the square, first I want to get something in the form x squared plus something x. Let's call it bx for now. So that's kind of the form we had when we were playing that guessing game with the, x squared plus 10x plus, and then we would say 25, or x squared plus 4x plus, and then we would say 4. Right? So we want something in that form. Well, to get it in that form, first we're going to have to get rid of the 1. So let's just subtract 1 from both sides right now. 3x squared minus 5x minus, or plus 1 minus 1, so equals -1. Just subtracting 1 from both sides. And now we want to kind of isolate this x squared. We don't want to have a coefficient in front of it, so let's divide everything by 3. That gives us x squared minus 5x, or sorry, minus 5 over 3x equals -1/3. Okay, so now we have x squared on the left-hand side, x squared minus 5 over 3x. So this -5 over 3 can be our b, and we can complete the square. In order to do that, we have to take half of this term right here and then square it. So half of 5 over 3 is, or half of -5 over 3, I should say, is -5 over 6. And then we square it to get positive 25 over 36. But wait, what did I just do? I just added 25 over 36 to this left side of the equation. So I'm going to have to do the same thing to the right side of the equation. So then we've got -1/3 plus 25 over 36. Alright, now we're good. The equation is balanced and I have completed the square. But now we know that if this is a perfect square trinomial, we can rewrite it as x minus 5 over 6. Sorry, x minus 5 over 6, or x plus -5 over 6, however you want to say it, squared. So let's go ahead and rewrite the left side of the equation that way. Is equal to, and then we have -1/3 plus 25 over 36. Well, 1/3 can be rewritten as 12 over 36, so -12 over 36 plus 25 over 36, and then 25 minus 12 is just going to be 13. So we've got, let me move this up here now, x minus 5/6 squared is equal to 13 over 36. Now, what do you think we can do now? Well, what we can do is we can take the square root of both sides, right? Remember, every number has 2 square roots, so if this number squared is this number, then this number must be either positive or negative square root of this number. So x plus 5 over 6, taking the square root of the left side, is going to be the positive or negative square root of 13 over 36. because every number has two square roots, and I don't want to just take the principal square root of both sides, I want to account for all possibilities. So we've got x plus 5 over 6 plus positive or negative square root of 13 over 36. Wow, this is getting complicated, but we can simplify it just a little bit if we rewrite this fraction as the square root of 13 over the square root of 36, and then we'll make this one positive or negative. We can go ahead and make this one positive because we've already accounted for the positive or negative up here. And then the square root of 36, of course, is just 6, so we have square root of 13 plus or minus over 6. So x plus 5 over 6 equals plus or minus square root of 13 over 6. Now to solve for x, all we have to do is subtract 5 over 6 from both sides. Let's go ahead and do that right here. X equals negative 5 over 6 plus or minus the square root of 13 over 6. And look, these all have the same denominator already. Isn't that convenient? It turns out it'll always be like that. And so we can rewrite our final solution as x equals negative 5 plus or minus the square root of 13 over 6. Let me write that a little bit bigger by just taking this thing and moving it over to here. So we've got x equals negative 5 over 6 plus or minus the square root of 13 over 6. And we can rewrite that as x equals negative 5 plus or minus the square root of 13 all divided by 6. And that is our solution for x. Now, notice that when we factor a trinomial to solve that way, there are usually two solutions. In this case, it looks like we only have one solution, but this plus or minus says that there actually are two solutions. So the two solutions would be x equals negative 5 plus the square root of 13 over 6, or x equals negative 5 minus the square root of 13 over 6. So this plus or minus here indicates that we do have two possible solutions, as we should expect. And that is one of the uses of completing the square. We weren't able to solve this by factoring, but when we completed the square, we were able to solve it. And we could actually go ahead and plug this value right here into this trinomial and see if it works. I'm not going to torture you with that, partly because I don't want to do it myself, but you could do it. In fact, I would encourage you to if you feel like torturing yourself. Alright, thanks for watching. I hope that gives you some insight into why completing the square is so helpful. Now you see what I mean, by the way, when I said that I could sit here all day and try to factor this thing and I wouldn't be able to do it. That's because I would have had to come up with something like this, and just coming up with something like that off the top of my head would have been really hard.